Welcome to the STEM Pathways podcast, where we delve into the fascinating world of science, technology, engineering, and math. I'm your host, Rohan Sharma, a passionate explorer of all things STEM. Each episode, we bring you captivating stories, cutting edge research, and inspiring interviews with experts and enthusiasts who are pushing the boundaries of innovation. Whether you're a student, a professional, or just curious about how the world works, join us as we unlock the mysteries of the universe and explore the endless possibilities of STEM. Let's get started. Today, I'll be interviewing Ankit Kaul, who holds a Ph.D. from Georgia Tech in electrical engineering. How are you doing today?
I'm good, Ron. How are you?
I'm doing good as well. So to
Thanks for
start
the
off,
thanks for the invite.
thanks for coming on here. So I wanted to ask, what made you choose your major in college?
Before I start, just want to say that all responses and answers in this interview are my personal opinion, and they don't bear any connection to any organization. Um, so your question on what made me choose my major in college, it's an interesting one. I would say that at first it seemed to be the least hardest choice for me, something that would naturally, nat I was naturally inclined to when I was in high school, which was math and science. And that's the reason I chose electrical engineering as my major.
Mhm. And what was your experience like while getting your bachelor's?
So my bachelor's was it was an interesting experience, a lot of learning. To give a little bit of background, I grew up in the city of New Delhi, close to New Delhi in India, and then for my bachelor's, I wanted to move out. I wanted to go to a different city and explore a new culture and meet new people. That's how I landed up in Bangalore for my bachelor's. And my experience was that both from a technical and a social or a cultural perspective, I I I learned a tremendous amount, during those 4 years. And as far as say the technical content of the course itself is concerned, it could have been much better. It could have been better. The format we typically follow in some of the undergrad institutes in India is you're given a set of courses that you have to complete. You're not allowed to do a lot of choosing or like modification, and so you're sort of set in a path of learning. So that could have been a little different or a little better in my opinion. But besides that, I thoroughly enjoyed, made a lot of new friends, picked up a new language, and yeah.
Yeah. So what did you do after getting your bachelor's?
After my bachelor's, I was split. I didn't know what's next or what's best for the path forward. And what I thought was, um, let me give industry a shot and see how things go in a couple of years. So what I decided was I'll take up a job, and I was lucky enough to land uh, a very interesting job profile at an avionics company. And I thought I'll take those couple of years to decide what's next. And somehow made my way through to grad school, and we can talk about that more as well if you're interested.
Uh, yeah. So what did you do during your master's?
Right. So, sorry, 1 second. My temperature seems to be a little different here. So what I did during so what happened at the end of the first year of my industry, uh, stint after my undergrad was in the first year itself, I realized that I, this job is not challenging enough, and many other roles around me at different companies didn't seem enough, enough of a challenge for me. And I thought I definitely want to study further. That's the next logical step. but I wasn't sure what to take on. Do I want to be in a technical master's, or do I want to be in a business-based degree, or do I want to do something else completely like administrative services and so forth? So I tried my hand at everything and eventually decided that, um, I'll go for a technical master's in electrical computer engineering, and see how, what what it offers, see how that experience goes, and then decide what to do further. So I picked up. I initially wanted to study analog electronics. So I had a background in analog, like system level analog circuits, and I wanted to study that. But when I arrived at grad school, I realized that, at first I realized it didn't seem to be a very lucrative option as far as industry is concerned. At least, the number of opportunities I could see around. So I ended up studying a mix of computer architecture, which was a completely different field of study for me. I had never, read anything, even heard about it before, and digital systems. That is what that's kind of what my focus was in the master's program.
Mhm. And then after getting your master's, what made you want to get a PhD?
Great question. I knew maybe you were going to talk about this. So initially, as I said, I never intended to do a PhD. I was actually against the idea of a PhD. I thought it was too long of a commitment, and both, not just financially, time wise, but also say socially, it could be taxing. I was aware of the challenges. I didn't think much about the pros or the benefits, so the cons were weighing out for me. But again, the same thing, the same story kind of repeated after that 2 years of industry experience after my bachelor's. Um, it felt like the same story all over again when I started grad school. Within the first semester, I would say 1 or 2 semesters, I realized that most jobs, at least in my uh, experience, seem to be something that you learn in a few years, a couple of years, and then it kind of becomes monotonous and growth seemed to stagnate. So that's when I realized, that within those couple of semesters in my master's program, I realized that, if I want something challenging, which has been my theme throughout, I need to go for research. And I was actively working, as independent research with professors during the master's program. But I knew that, I had to do something original, that I could call my own, and that's kind of what led to the decision.
Yeah. So what was your research about?
My research was in the area of semiconductor packaging. So I was looking at different ways of the different physical challenges of integrating emerging devices, no, non-conventional or non-unconventional devices, in some of the advanced packaging formats. And what I mean by that is, if you imagine that a conventional transistor, it started off as a CMOS device, which was like one of the basic forms of compute, and it evolved into different kinds of devices for logic, memory, and so forth. So, and now, today we have FinFETs and even more advanced devices for compute. And as far as memory is concerned, we have not significantly evolved. Like the basic type of the best type of memory devices that are out there are called as static random access memories, SRAMs, which are great for fast operation, and efficient too, but they don't necessarily give you enough density. So they're emerging. Long story short, they're emerging devices out there, ones that are not just based on capacitance, but also things like resistive random access memories. They are based on the value of a resistor changing as a function of the voltage you apply. So point being, they're emerging devices, and which have been explored or have been proposed in academia or in industry, but the integration of these devices has not been explored yet. How best can we put them together to get an efficient and a system that you can deliver power to efficiently, and also doesn't the thermals don't become don't be a won't be a challenge, the thermal
Yeah.
operation. So that was my area of research. I was focusing on computational modeling of these advanced integrated architectures.
So correct me if I'm wrong, but I heard Georgia Tech is very good at packaging.
Mhm.
Uh, what makes them stand out compared to other colleges?
Interesting question. I would say there are a couple of things um, that stand out. One is that Georgia Tech, as far as semiconductors is concerned, I see that they've taken a holistic approach. They don't just focus on one part of the stack. When I say stack, I mean, say, just circuits or just software, right? Like in semiconductors, everything is important. To make a great hardware or a great GPU, you need to have a full scale solution that your customer can just take and start using off the shelf. So what they've focused on is great coursework across the stack. They have good coursework in architecture, computer architecture, good coursework in packaging, which is again, how do you can build these semiconductor devices or circuits or chips, but how do you put them together efficiently? And I can go into the details of why that is important, why packaging is important if you are interested. But they have taken a two-step approach. One is providing good coursework, which includes labs as well, not just theory, by the way. So you can actually go and build things in the lab even at an undergrad level. And the second thing is they've established a good industry-wide network, and across not just like industry and academic network, and they've invested in building the cutting edge, getting the cutting edge tools and frameworks needed to build and do this research in packaging. So they have good courses and great faculty and lab support.
Yeah.
Yeah.
So what'd you do after getting your PhD?
Oh, so I was confused what I wanted to do with my life, and eventually decided that academia is probably not a path for me right away. And I leaned more towards industry because I wanted to see the things that I work on come to fruition, come to like happen in real life, and in applications of theory and research. So I ended up taking up a research role with Advanced Micro Devices, which is AMD, where I am a member of technical staff in the packaging division.
Mhm. So for my last question, I wanted to ask if you had one piece of advice to give someone who's still in high school or early in college, wanting to go down a similar career path as you, what would you say?
That's a great question. I would say I would follow a two-step approach in my mind. One is focusing on detail and basics is crucial for doing well in any field, right? Any area that you want to do well, you want to be the best. Focusing on detail and basics is important. So um, when you study, when you're going to go to school, when you interact with your peers and your teachers, always ask questions. Whether you feel it's very basic, it seems silly, but don't be afraid to be the silly one asking the basic doubts. So focus on detail and your basics, get them strong. And the second I would definitely say is something that you seem to be doing very well, which is network and reach out and get exposure to different um, kind of things that are out there. And this will help you make an informed decision. We always wonder, okay, I've taken up this course, or I've done this project. Now what's next? I finished my high school. Now I'm going to pre-university, or I want to go to college, but I don't know what to study. So the only way to make a great decision, or maybe know your niche, right, is to talk to people and see what's out there and what's happening, what they're working on. So these are the two key things I think are can be beneficial in being successful.
All right then. Thank you for joining me on the podcast today.
My pleasure. And thanks for having me. It was great talking to you.